applications of differentiation and anti-differentiation. We focus on differentiation. Okay, we don't use anti that much yet. So we focus on differentiation. Tangents and normals. So what are tangents? What are normals? Let's just do not worry about like what I write here. Well, if you can't remember what to do, you can remember the steps. Otherwise, you can go through like you can remember what we should do. So let's say we have a graph. Just sketch any graph you like. On x and y. Well, I'll sketch a graph like that. I want to find the tangent at that point. Let's say that function is fx. Then this point is a comma b. Let's say b is fa. B is fa. Like a point on the graph. I want to find the tangent at this point. Well, you have tangent at different points because that's why your gradients keep changing. Then I can find the tangent. The tangent is the line. Only touch it once. That's not once. Wait, just so hard to sketch. Okay, that's the line only touch once with this graph, with this function. Okay. What is the gradient of this tangent? What is the gradient of this tangent? Anyone knows that? It can't be B on A. What's the gradient of the tangent? What's the representing? I always ask you this question. The derivative. The derivative at that point. So the gradient at that point is f dash a. Is the derivative at that point, f dash a. Okay. Then how we can find this linear? How we can find this linear? This linear, what we know about this linear? I know the gradient of this linear. I know a point on this linear. So therefore, I can use y minus y1, which is fa, equals to gradient x minus x1. Y minus y1 equals to gradient x minus x1. You know the formula? I know the gradient of the linear. I know one point on the linear. Therefore, the formula we use is y minus y1 equals to m x minus x1. So x1, y1 are a pair of points on the graph. And then m is the gradient of that point, of that graph. And then the next thing is called the normal. What is the normal? Normal is at the same point, is a perpendicular line to the tangent, is called the normal. So the contact point is a comma b. That's the contact point. Okay? Three graphs all intersects exactly once at that point. The tangent, the normal intersects at the same point, and the graph pass through that point exactly once. Okay, so A and B on three graphs. Some three graphs: gradient, tangent graph, normal graph, and original graph. So what is the normal? What is the normal? What's the gradient of the normal? Is -1 over f dash a. The tangent is f dash a. For example, f dash a is 2. Then the perpendicular line's gradient must be -half. Must be -half. So it's negative reciprocal. Okay, negative reciprocal. So I can find the gradient of the normal. At the same time, I know the point AB is still on this normal. I can again use the formula y minus y1 equals to gradient x minus x1. And then rearrange it to make y to be the subject. I can find the normal equation. I can find the normal equation. So, overall, what we need for finding gradient or the normal, I need two things. First, I need the gradient of the tangent, which is f dash a. Second, I need a contact point. Contact point are the point on three graphs. The contact point. I just need two things. Overall, I need two things, which is f dash a and the contact point a, comma fa. I just need those two pieces of information. Okay, I just need those two pieces of information. Okay, example 1. Find the equation of the tangent for that graph at the point x equals to 1. So when x equals to 1, I need two things. I need the contact point. So what is my contact point? Contact point needs both x and y values. So when x equals to 1, y equals to 1 cubed plus a half times 1 squared. Y equals to 3 over 2. So the contact point is 1, 3 over 2. Right, I'm finding the tangent at that point. So that point must be on the tangent as well, which is 1, 3 over 2. Remember, contact point must be the point on the original graph, on the tangent, also on the normal. Okay, it must be three graphs intersect at one point. That point is called the contact point. Okay, second is the gradient. If we mention gradient, I must have dy dx. That's 3x squared plus x. 3x squared plus x. So when x equals to 1, the gradient equals to 1. So it's f dash 1, right? It's f dash 1. So the gradient equals to 4. I sub 1 in. So 3, 1 squared plus 1 is 4. Therefore, I know that the linear has this pass through this point, 1, 3 over 2, has a gradient of 4. I can go y minus y1 equals to gradient x minus x1. Y minus y1 equals to gradient x minus x1. That's y equals to 4x minus 4 plus 3 over 2. That's y equals to 4x minus 5 over 2. So that is the tangent at that point. That is the tangent at that point. Or you can use another method if you can't really see it. What you can do is, let's say the gradient of the tangent is y equals to 4x plus c. Well, the gradient is 4, so it must be 4x. The gradient must be 4x plus c. I don't know the c, so I work out the c. It passed through the point 1, 3 over 2. It's definitely passed through the point 1, 3 over 2. So that 3 over 2 equals to 4 plus c. c equals to negative 5 on 2. So y equals to 4x minus 5 on 2. I can do by this way as well. By substitution, I can make sure what's the gradient. I just need to find out the intercept. But I will recommend the first method, because when you have some really terrible numbers, do the substitution way is not that easy. You can just find out, like I can directly find out answer by using this method. Well, when you have some not very nice calculation, the first one will got some advantage. But like, you can do both. Okay, you can do both. Okay, that's example 1. And have a look at example 2. Find the equation of the tangent to the curve fx equals to that. Yeah, I want to find the equation of the tangent to the curve, to this curve, at point cross the x-axis. So what is the point cross the x-axis? What's 0? x0 cross x-axis is what 0? y0. Okay, it's y0. Basically, I'm looking for x-intercepts. Cross the x-axis is looking for x-intercepts. Okay, give you 1 minute to find out the x-intercept for me. There's a revision on polynomial. Okay, a revision on polynomial. What the graph looks like. Think about what the shape of the graph looks like. Any questions, everyone? I will have y equals to 0. I'm solving that polynomial equals to 0. As the method I used before, I discourage using long divisions. I put the coefficient of each number in order, like 2, -3, 6, and -5. And I choose the number to try. Like, I will see 1, maybe a reasonable answer to try. I put 1 in. And then the first number already, like, always directly coming down. So that's still a 2. So 2 goes times the 1, and then plus the next number, -3. That gives you a -1. The -1 go back to time with the 1. Give you -1 plus 6, give you 5. 5 times the 1 plus the next number, -5, give you 0. So it is a 0 in the last box, which means that is a factor. That is a solution. So 1 is a solution. X minus 1 must be a factor. So I have one factor, x minus 1. The good thing about this table is what has been left is already the coefficient for the remainder function, so the rest function. So you have a linear, that one must be a quadratic, what has been left. So it's 2x squared minus x plus 5. That's the next part of the function. So two factors, one linear, one quadratic. And I can try the quadratic. B squared minus 4ac is a negative number. I can't further factorize that. So that is only one solution, which is x equals to 1. Okay, if it's x equals to 1, if you think about the shape of the graph, that will roughly look like that. You only have one intercept. You start from the right top and go through that point, go through the y-intercept, but you still maintain the cubic shape, but it can't go up to the x-axis, so you will have a wave like below, and that's the shape of the graph. And you want to find the equation of the tangent at this point. Okay, you want to find the equation of the tangent at that point. So you know that the contact point is already 1, 0. You find that out already. 1, 0. And I need to find f dash x. I need to find the gradient, which is 6x squared minus 6x plus 6. 666. Okay. 6x squared minus 6x plus 6. I need f dash 1. So 6 minus 6 plus 6. What I have? 6 again. The derivative is 6 at x equals to 1. So y minus y1 equals to 6x minus x1. So y equals to 6x minus 6. Well, it's a 6 number. Okay, that's how we find the equation of the tangent. Okay, that's how we find the equation of the tangent. Okay, what the two things you need is the contact point and the gradient at that point. What is the contact point? Contact point must be the point on 3 graphs. Okay, on all of those 3 graphs. It must be on the original graph, on the tangent, also on the normal. That is called the contact point. Other points is not contact point. Okay, what I need is just that one. Okay, just that one. All right. That's finding the equation of the tangent. Let's have a look at the next one. Next one says how to directly look example 3. Okay, directly look example 3. Find the tangent to the coordinate, which at this point, the tangent to the curve is parallel to the line, y equals to 3x plus 2. I have a graph. At a point, the gradient, the tangent is parallel to that linear. That linear is 3x plus 2. Okay, what I'll do is, I can have a think what information we have. What the parallel tells you. Gradient is the same. Okay, parallel tells us the gradient is the same. So gradient is the same. Tell me f dash x equals to 3. Okay, f dash x equals to 3. So what is f dash x? F dash x is 2x minus 6. That equals to 3. So x equals to 9 over 2. That is the x value of the contact point. Because at the contact point, the gradient is 3. Therefore, 9/2 is the x value of the contact point. And I need the y value of the contact point as well. So I'll look for y. Well, I have -7/4. I'm not sure what you get. So that's the gradient. So gradient of tangent is 3. Okay, it's given. So I want to find the equation of the tangent. Okay. Equation of the tangent. That must be y minus y1 equals to gradient x minus x1. Okay, that's what I get. I'm not sure if it's correct. Just check it. Yep. Have a think how you can find the equation of the normal. That's the tangent. The line perpendicular to that is called the normal, but also needs to go through the same point. What's the same point? Is the contact point. Okay, the same point is the contact point. How do you find the normal? No, it's just the same question. How do you find the normal? What's the gradient of the normal? -1/3. Okay. What's the gradient of the normal? Okay, -1/3. It must be perpendicular to the tangent. That's negative reciprocal. Okay, negative reciprocal. So you always pass through the same contact point for tangent and normal. So what we will have is y minus the same point equals to, just change the gradient. That's what we need. That's the normal. The only thing I have changed is the gradient. The gradient of the normal is the perpendicular one. If the tangent is 3, then the normal must be -1/3. It's negative reciprocal. But it passed through the same point. I can still use the same formula, y minus y1 equals to gradient, x minus x1. So that's y equals to -1/3 x plus 3/2 minus 7/4. That's a 6/4. Y equals to -1/3 x minus 1/4. Okay, that is the normal. Okay, that is the normal. Okay, now we have to go through all the easy questions. Okay, all the easy questions like how to find tangent line, how to find normal line. That's a really straightforward question. But let's have a look at a hard question. How it can be hard. Okay, in which ways the tangent normal question can be hard? Is not really likely to appear, but like I see it once. I can't find the original question, so I make up one question. The number will not be nice, so I will say you can use CAS for this question. But let's read the question and find out what's the problem. I want to tell you one thing from this question. There's something wrong. Okay? Well, it's not something wrong. You need to recognize something. Okay, let's read the question first. It's a really short one. The equation, find the equation of the normal. Okay, it's nothing different compared to find the tangent to the curve with equation that at the point 1, -1. What you can do to this one? The gradient at where? Well, it must be a question different from the top. Otherwise, I will not put it in the end, and I won't say it's a hard question. You need to recognize what's wrong, like not really wrong, like what's different. It's only 2 pieces of information. You have an equation, you have a point. What is that point? What is that point? Where is that point? Let's say. Where is that point? Well, I don't really care about the quadrant. I care about more whether it's on the graph or not on the graph. Is it on the graph? No. Okay, if it's not on the graph, everything will be different. Because before is I know the contact point, but this point cannot be a contact point anymore. Because what's contact point? I emphasize a lot of time. Contact point must be the point that intersects at 3 places. That's called the contact point. But this one is not a contact point. It's already off the graph. Okay, it's not on the graph. So let's sketch this function first, like x cubed plus 2x squared. Let's sketch it. I would exactly draw to you which point we're looking for. Yeah, what we're looking for. Okay, that's roughly the shape of the graph. Let's not, I can't draw a beautiful shape. Oh my god. Okay, that's just like that. Well, it's not really. I hate this. Okay. Just like, I'm not going to change it. 1, -1. Okay, 1, -1. -1 is here, but like it's not on the graph. Obviously not on the graph. Okay, it's already in the 4th quadrant. Okay, what this question tells us is the normal line passed through this point. Okay, the normal of the curve, or at a point passed through this 1, -1. I don't know where is it. But what I can sketch is, I can sketch a graph for you. I'll just sketch it here. It's not very... Can't find a good way to sketch it. Oh, okay, this one is good. Roughly here. Okay, roughly here. At this point. Can you see I draw the red one is the tangent. And then I connect the contact point, and this one negative one is just perpendicular to that. Approximately. I haven't said anything yet, I just say approximately like that. Okay, what I want to find is this green line. What I want to find is this green line. But basically I know nothing here. Okay, basically I know nothing. So again, if it's a tangent and normal question, I always need the contact point and the gradient. So now I don't know the contact point. How about I just give a contact point? Let's say that point is a comma a cubed plus 2a squared. I don't know what is it, but I can say it's like that. How you can represent the gradient of this linear, the tangent, the gradient of the tangent in terms of a. In terms of a, can you give the gradient of the tangent? Is f dash a, right? Well, dy dx at x equals to a. So what is dy dx? Is 3x squared plus 4x. So the gradient m at this point is 3a squared plus 4a. Okay, now my question is, what is the gradient of this green line? What's the gradient of this green line? Yeah, perpendicular to that. So what is it? Negative 1 over 3a squared plus 4a. That's the gradient of that green line. Well, I just don't know the exact number, but I can just definitely do in terms of a. So at a point, I have gradient f dash a, and I must have the gradient of the normal is minus 1 over f dash a. And I know my contact point must be a comma a cubed plus 2a. Okay, now I want to find a way to talk about. Can you see the a comma a cubed plus 2a squared and 1 negative 1 are on the same line? So I can use y2 minus y1 over x2 minus x1 equals to the gradient. Equals to the gradient. Right? The gradient of that line is minus 1 over 3a squared plus 4a. Therefore, the 2 points on the curve, I've used y2 minus y1 over x2 minus x1. I can find the gradient. Then the gradient is that. Right? I can find out that. And I can solve for a. That's the equation. I can solve out a. But I put that into the calculator. Well, I'll tell you, if you solve it, it's not a whole number. It's just something 2 point blah blah blah. Like, it's not a good number. But after you work out a, after you solve out a, solve for a, and then find normal. So how do we find normal? Y minus y1 equals to mx minus x1. So you know your x1, y1. So x1 equals to a, y1 equals to a cubed plus 2a squared. And then your m equals to minus 1 over 3a squared plus 4a. So you just work out every single point according to a and put that back into the equation. I'm not going to ask you to really work out this value. It's too hard to calculate. But it's the idea. It's the idea of this question. So the point given is not necessarily tells you the point on the curve. You need to check when a point is given, whether it's on the curve or off the curve. If it's off the curve, which means you don't know the contact point, and you need to set up a general contact point by yourself and then try to work on that. So I'm not going to ask you really solve for it. It's just like you can do up to this point, and that's so good. Alright, any questions about that? It's a good question. It wants you to think about it. You can solve out 2a values because you can on this side find another like point which is somewhere around here, and then I have a normal here. Okay, I have a normal here. So it's 2 normal actually can pass through 1, -1. You can solve for the function and you can find out 2a values. You can directly solve out 2. You don't need to consider how many I can have. It's directly by solving, and you can solve out 2, and then you know that's 2 points. Okay, that's 2 points. Any other questions? Okay, if no, you can work on this exercise by yourself now. I'll just stop here.